Displacement versus distance. Displacement is the distance from an arbitrary starting point at the end of some interval. It is the difference between ending position and starting position. In this velocity function graph, red is the starting point. We go up 2 units, down 4 units to reach -2, and up 2 units to reach 0. Assuming that the triangles are of the same size, the area of each triangle is the same. So, when you add the area of both, this one is positive, this one is negative, you get 0. You also know that the displacement is 0 because it starts at 0 and also ends at 0. The displacement can be represented by the function the integral of velocity from A to B. Distance is how far an object traveled regardless of direction. In the same velocity graph, the absolute value of velocity represents the distance. And so, when the areas of the triangles are the same, they don't equal 0. As we know, the speed is the same thing as the absolute value of velocity. Distance can be represented by the equation the integral of speed from A to B. And so, the integral of the absolute value of velocity is A to B. This triangle is flipped because when you take the absolute value of a negative, it becomes positive. So, when do you use displacement? You use displacement when you are trying to find out how far an object ended up from its starting point. We can use a graph to solve it, or we can use an equation to solve it. Let's look at an example. Jimmy is riding his bike to school. He forgot his backpack and started back towards home. How far away is Jimmy from his house? This graph represents Jimmy's velocity. This is his starting point when he's at home. So he's going to school, and at this point he realizes he forgot his backpack, but he's still going towards school. At this point, he makes the decision to turn around and head back home to get his backpack. So, we have to find the area of both triangles. We do 4 times 2, which is 8, divided by 2 equals 4, the area of the first triangle. Then we do 5 minus 4, which is 1, times -2, which is -2, divided by 2 equals -1. So the area of the bottom triangle is -1. We then add both of the areas together to get 3. So the displacement is 3 meters. Let's look at another example. Given the velocity function equals 2x, find the displacement from time 0 to 3. So we know that the displacement equation is the integral of velocity from A to B. We plug in our bounds and our velocity function. Then we take the antiderivative and get x squared. We plug them in to FTC, the fundamental theorem of calculus, and get 3 squared minus 0 squared equals 9. So when do you use distance? You use distance when you are trying to find out how much of something has traveled regardless of starting position. Let's use the same example of Jimmy. And using the same velocity graph, we know that he starts at home, heads towards school, realizes he forgot his backpack but is still going towards school, and at this point, he turns around and heads back home. We know that the area of the first triangle is 4, and know that the area of the second triangle is -1. We also know that distance is the integral of the absolute value of velocity from A to B. Our A is 0 and our B is 5. And so, when we take the absolute value of both triangles, we get 4 plus the absolute value of -1, which is 5. So the distance equals 5 meters. The end. Brought to you by Manas Tiwari, Zach Edwards, and Julian Lobo.